Go ahead.
Okay, hi kids again, and today I'm going to show you a little thing which is how we do some of the measurements on the core. You see this bench here, where there is a rail where this core is actually being pushed by this instrument here, and it's got to go through some measuring devices here. We use two on this expedition to measure some physical properties of these gabbro cores. The first one here is an instrument we use to measure density. The density of the rocks is somehow a measurement of how heavy they are, okay? And to measure that, we actually use a small radioactive source here, which will emit radioactive gamma ray, and we will measure the gamma ray on the other side. That's going on now. The core is going through this measurement device. And the amount of gamma ray which is absorbed by the core is proportional to the density, which is a property which we want to evaluate. It's a little bit like light going through your sunglasses. There is less light going through your sunglasses than your regular glasses if you wear some. And this is pretty much the same idea. The darker the glass, the less light goes through. The denser the rock, the less radioactivity goes through. Okay? Then the second instrument here, which is this white thing here, is called a magnetic coil. And by pushing the core through this stuff here, we are trying to measure the property called magnetic susceptibility, which is a measurement of how much magnetized the rock is. When these rocks form, when they cool from a magma to become a rock, or crystallize from a magma to become a rock, then they acquire some magnetization from the Earth's magnetic field. And how much of the rock can acquire, how much magnetized the rock can be, it depends on how much magnetite there is. Magnetite is that mineral which behaves a little bit like a magnet in the rock. So we're measuring this here.
Thanks, Benoit.